Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to Keith Higgins, VP of Marketing, and Nithiya Parameswaran, Executive Product Management at Rockwell Automation. Rockwell Automation is one of the largest and most well-known companies in the industrial automation sector.
My name is Keith Higgins. I'm the Vice President of Digital Transformation at Rockwell. Nithiya, would you like to also introduce yourself?
Sure, Keith. Hi, I'm Nithiya Parameswaran. I'm the Enterprise Analytics Leader, managing the analytics portfolio for Rockwell.
Terrific. So I thought what we do is, fairly quickly just kind of walk through a little bit about, Rockwell's role today in digital transformation, the investments we've made, and, a little bit of a company thumbnail. So Rockwell is, over 100-year-old company. It has 23,000 employees globally and largely has been very successful in industrial solutions, including things like control and automation systems and whatnot. And then about 2 years ago, the firm invested $1 billion in a firm called PTC. And jointly, the two companies have created something called Innovation Suite, which is software specifically built for OT, IT convergence and the higher value use cases that industrial organizations can derive from really understanding the insights that can be generated from the data in their infrastructure. And so I won't do death by PowerPoint, I promise. I can give you just a quick example of some of our customers that have more recently done large digital transformation expansions with Rockwell. You can see some of those logos. Obviously, the company does a lot of work in virtually every major industrial vertical industry today and across a range of applications. But what I thought I would get to is, I won't go through the obvious, right? Which is, pretty much everybody recognizes the value of digital transformation and that moving early has quite a bit of results. And we can send you this presentation after today if there's any of this material that you'd like to look at. But primarily the customers that we work with today are looking at generating a return on investment across multiple dimensions. How do I increase my revenue and get products to market faster? How do I drive out costs? And I think what we're going to zoom in on a little bit today is how do I really improve my asset efficiency? An asset could be a device, it could be a line, it could be a plant, things along those lines. And so these are the ranges of value that we've seen in a number of use cases that have been deployed across our customers. We do have quite a broad ecosystem of partnerships. This is one space in the industrial IoT where we expect that partners and having an architecture designed for interoperability will be extremely important. This is a conceptual view of the FactoryTalk Innovation Suite platform. And without getting into too much of the technology, it is designed for very rapid data ingestion across a variety of sources that exist today. The ability to provide manufacturing execution systems, or what some people call manufacturing operations management, which has a lot to do with integrating with existing IT systems such as ERPs, integrating with things like supply chain, making sure that you have a good tie-in to your things like process and quality management all the way through, your control automation infrastructure, and then the analytics piece on top. And on the right, you see largely what we've integrated with our partner PTC. There are two primary platforms being ThingWorx, which is their industrial IoT platform, and what they call Vuforia, which is getting a lot of attention today in this COVID environment because of its augmented reality and remote access assistance capabilities. So I'll go to this slide, and then I'm going to hand it over to Nithiya. But I think the idea today was to talk a little bit about predictive maintenance. And this is the entire solution suite that we've productized with PTC, everything from the augmented worker and broader enterprise operational intelligence and really the MES piece we talked about earlier with production management. But if we zoom into the second column from the left around asset optimization and maximizing that, that's really where we get into things like monitoring health, predicting downtime, predicting anomalies, looking for indicators of of anything that might impact production. And so what I'll do maybe there is pause for questions, and maybe Nithiya, I'll hand it over to you to kind of talk about asset optimization and predictive maintenance, and I'll go to a slide that I think kind of spans some of those areas. So this might be a good talking slide for you potentially.
No problem. Thanks, Keith. Any questions so far before I kind of talk about some of the capabilities we have in the predictive maintenance area?
I'm making notes of questions, and I'll ask later on if you don't mind, both of you. I'll leave it for now. Is that okay?
Sure. And just to be cognizant of the time, like how much time do we have? We started a little late. So
I'm flexible, but let's say, I don't know, usually they last about 30, 40 minutes, up to an hour if they're really long, but we've done about 10 minutes so far, 15 minutes so far, haven't we?
Okay, so I'll spend maybe another 5-10 minutes talking about the capabilities we have in the maintenance space. So actually, if you look at our customer base in the manufacturing side, like we play a big role right from automation close to the actual asset to providing value at a much higher level. So if you look at our target persona, right, with these products, it's an automation engineer who requires a certain set of capabilities. We also want to provide capabilities to the plant engineer. We also have this population of data scientists who kind of take data from not only from the automation assets, but also from ERP and other systems to kind of get the data together and get more insights and provide more value to customers. Then we also have like the citizen data scientists, right? So these may not be your pure data scientists, but also they're kind of in between. They know the domain, and they also know how to use some of the analytics tools. So when we have these products, we have offerings or capabilities to target some of these very specific user persona. Now, also the products fall into different categories in terms of the quicker time to value. Like how can I provide value to the customer as quickly as possible versus where there are cases where a business problem to be solved requires data from different sources, getting the data together, stitching it, cleansing the data, and then creating a model on top of it. So there are varying ways of doing predictive maintenance depending on your business problem that you want to solve. And in Rockwell, we have capabilities to address not only the persona, but also how we can quickly provide time to value. Now, for example, so we have one of the product where it sits really next to the controller, right, which controls the equipment. And as you plug in, what it does is it goes to the network, tries to find all the devices that that particular controller controls, and provides status of that particular controller on the device. Like, is it on or off? Am I seeing any fault in it? And am I seeing anything that is an anomaly? And I can trigger an action to it. Or if I'm seeing a problem with the particular device or an asset, is there an action card that I can suggest to the maintenance person? So this is a capability where it's a plug and play. It's a module that goes and sits right next to the controller. It can talk to the controller. It identifies the devices because we already populated that particular module with all the device profiles. So already we have the profiles built into it. So it can easily recognize those devices and provide information within, I would say, like less than a couple of hours, right? So it can, because it knows the profile, it can identify and start showing value. So that's one thing. But we also have capabilities where we want to bring this artificial intelligence or machine learning right close to the controller. So we have another capability where it can look at some of the variables that are of interest and create a ML model out of that and then start predicting or showing anomaly. So we call this as more, like where we take the mathematical models out of the picture because already pre-packaged inside the module. The target persona here is the automation engineer who knows about the process, who understands the asset and how it operates. And now they can configure this device to say, you know what, out of the 20 variables that I'm getting out of this particular device, my biggest interest is quality. Let's say my quality can be moisture content in a package. Now, one way to measure the moisture is to actually open the package every 5 minutes as it comes out of production line and measure the moisture content inside. But that's a big waste, right? Now, can I use a soft sensor technology, which is using the other variables? Can I predict what would be the moisture inside my packaging? So it reduces waste, it reduces stopping the line, but the model, again, the automation engineer has full control of how the ML model is built. The automation engineer doesn't need to know what kind of regression analysis is doing or correlation analysis is doing because all those are pre-packaged. And what the process engineer is more interested in is like understanding the result and fine-tuning the variables that he or she thinks is more important to that particular moisture as the variable of interest. So we have capabilities there. But we also provide a development environment where data scientists can pull data out of these controllers, pull data from ERP systems or EAM system, now marry the data because ERP EAM system also has data about the asset performance. It also has data about what is a production schedule for the particular asset, the maintenance schedule from the EAM system. So bringing all this together and also any repair history, now you can provide even more insights and a different set of predictive insights that you can give. However, somewhere sitting in between an extreme data scientist who's pulling all the data together, wrangling the data, and then providing analytical models, versus you have these modules which are hardware sitting right next to the controller. We also have an intermediate solution where using the libraries like Spark libraries and ML libraries, we pre-package certain offerings which are addressing a very specific use case. Like for example, anomaly detection, right? So again, this is targeted towards the plant engineers, either it can be process or manufacturing or maintenance. But the offering is, one is for anomaly detection, one is for predictive maintenance, one is for model process control. And again, it's going to be used by the plant engineer. They understand the variables, they can look at the data, they can identify what are those data points that are outliers, which doesn't fit a normal operation, clean that data, and then run these models and see the results. And when they're happy with the results, now they can actually apply that model, right? Again, they don't need to know like what is the algorithm that's being used, what's the library that's being used, but we already pre-package it. So that's kind of where we have different products targeting different personas, targeting specific use case, but all around providing more asset efficiency, process efficiency, and reducing downtime, and how we can alert as quickly as possible based on what we are hearing from the asset and the device. So that's kind of a very quick overview of the set of capabilities we have. I didn't get into the product names because product names takes to different areas, but at least these are the capabilities we offer as part of predictive maintenance for our customers. I'll stop here and take some questions.
Okay, thank you very much, Nithiya and Joseph. What I'll do is I've got a list of questions. If you don't mind, I'll ask them, and I'm not really sure who to direct them to. So if you could each sort of either volunteer or suggest each other for the answer. I'm also going to share my screen, specifically my browser, so that we are on Rockwell Automation's website, and maybe we can go to certain parts to maybe you know, to emphasize what we're saying or explain better what you're talking about. So the one that I wanted to ask is the first question I wanted to ask is very basic, and it follows on from what Nithiya was saying. I just wanted to make sure that I understood how a solution works. So a solution typically involves some hardware, which you said it sits next to the controller being a type of computer that controls machinery such as a robot and other things. Now that hardware that you're saying sits next to the controller obviously has software inside it that you know, can get very sophisticated and involves machine learning and so on. Have I got that right? Have I got the basic structure of it right? Is there anything else I need to consider or what in this typical Rockwell solution for an industrial customer?
Yeah, so the certain capabilities come along with the hardware, right? Because it's sitting right next to the controller. Like we have a product which is the, let me call it as a data scientist in a box, right? So it comes with a module that is the same chassis as the controller, and its communication is through the backplane. So it directly just talks to the controller directly there. And so that's a module you buy, right? But however, when we have capabilities for the data scientist, that's more a software piece where you install in an on-prem server, and then you bring the data, you can point the product to different data sources and bring the data together and cleanse the data, build models, and then you can deploy that model either at the edge, or you just deploy the model right there in your on-prem server itself. So the capabilities are available. It all depends on the use case, right? In certain cases, I want to have a very closed loop, fast analytics. In other cases, I need much more analysis. I need to take some strategic actions in order to fix the problem, right? So you have a gamut of doing predictive maintenance and detecting anomaly. Certain anomaly is you can control immediately by just fine tuning some of the parameters. In other cases, you need a strategic steps to fix that particular asset problem.
Right, and the type of data that is ingested, typically what is that data? It's probably too difficult to sort of generalize, but I imagine it's direct information about the machine, whether it's vibrating a lot, whether it's, I don't know, making a lot of noise, or what you know, in plain terms, what kind of data does it ingest, draw in or bring into itself in order to analyze that?
Sure, it can be the current that it is drawing. Let's say if we take a drive, or what is the torque, what is the speed, or what is the amperage that it is drawing, right? So these are typical parameters. It can be vibration, it can be the speed. It can also be the temperature. If it is a bioreactor or a mixer, it can be the temperature of the content. So these are the typical ones, and can go anywhere from 20 to 300 variables that we can collect at high speed.
Now, when you collect those variables, it then goes to some sort of artificial intelligence system to, suggest decisions for it. I imagine there's a hell of a lot of data for a human being to sort of collate and even simply look at, let alone make decisions about. So it must be going through some sort of AI. You call it machine learning. What does that part do? Does it make decisions and then act on those decisions in some cases, or does it always suggest things that the human then has to decide what to do? For example, switch off a machine or arrange maintenance for a machine or something. Can you describe in simple terms what the artificial intelligence does?
Yeah. So it depends on how the customer wants to implement. So there are cases where when you have analytics that can run at a very high speed and give feedback like less than for 4 micro milliseconds, then yes, you can actually send the instruction back to the controller to take the corrective action, right? So you have those capabilities, definitely. But there are other capabilities where it can just trigger an alarm for somebody else to take a look at it and act upon it. Like for example, I am seeing an anomaly in one of the device. There's an action card that goes along with that fault code, but you want to prompt the site engineer or the maintenance person the fault code and the action that needs to be taken in order to fix it. So you have both ways of communicating, right? You can send alarms and events to an external audience to take care of it. In certain cases where it is more about machine performance and where it's high-speed analytics, then there is a closed feedback mechanism where it goes back to the controller. But in this case, the model is being tested, it's proven, and then they deploy the model, right? So the provision is given to the automation engineer to first try it with historical data and see how it predicts these anomalies, right? And so they have historical information that they can compare how this particular model predicts. Now, once the customer is satisfied that I have a confidence that this can actually predict it, then is when they can actually send it the control back. Again, it all depends on the use case, right? In the example of what I said about moisture, there's nothing. If I see that my moisture, if I predict the moisture is not going to be good, there are 2 ways to do it. Either now I stop the machine and then actually measure the moisture, or I can have some control parameters that I can set back to actually control it. So it just depends on the use case and depends on what I am measuring and the variable of interest that I'm tracking.
Right, thank you very much for that. I've got other questions as well, probably 2 or 3 more. I'll try and choose between 5 or 6 that I've got. PTC, just a quick question first. PTC was that a product lifecycle management software? Do you know?
Yeah, so, they have a PLM software. They also have an IIoT platform called ThinkWorks. And where we primarily focus on, which Keith kind of covered, is where we are integrating our product with their IIoT platform, which is the ThinkWorks, and leveraging capabilities. And ThinkWorks also has a rich augmented reality capability, which we also want to take advantage for the industrial space. Keith, anything you want to add more to it?
Yeah, I apologize. I was on mute. So, we PTC's heritage in the PLM space with Windchill and Creo, and most recently the Onshape acquisition. Those are solutions that we work with in a digital thread type environment. The Innovation Suite platform itself, where we've done the OT-IT integration across our Historian, our control automation layers, and our MES system, is really with, as Nithiya pointed out, the ThingWorks platform, which is their industrial IoT platform. And then we also work quite a bit with the Vuforia solution. So, for example, starting the 1st of last month, jointly with PTC, we offered free use of Vuforia Chalk, which you can think of as an industrial kind of FaceTime product. to help our customers who now are having to work much more remotely. So we tried to give them a tool to help them really for free for 3 months in this, in this shelter-in-place environment, and that's been extremely well received. So I use that as an example where I think, as we at some point go back to a new normal, a lot of our behaviors may not, return to the same levels, right? Travel may not return to the same level. Working from home, may not return, to the same at the office may not return to the same level. So these types of tools, people are realizing that, post this environment we're in are going to, make them more effective, more productive, more efficient. And augmented reality, I think, will play a big part of that, including things like expert capture and whatnot.
Well, this I'm just looking at the screen and going to PTC. I find it. I didn't know about the Onshape. I don't know who's taken over whom. Has Rockwell bought Onshape and PTC?
No. Rockwell made a $1 billion investment in PTC, equity investment, which was about going on 2 years ago now. And as part of that, there was, quite a number of joint go-to-market activities that were a result of that, along with integration, because, one of the biggest things that will accelerate digital transformation is the pre-integration of the OT environment with new IT systems like the industrial IoT platforms. So that's what we've done with PTC completely separately. Maybe, I don't know, don't quote me on this, 6 months ago, they acquired Onshape, which was a Boston-based.
They meaning, they meaning PTC?
PTC, yes.
Oh.
It's one of the first, cloud-based PLM systems. In fact, there was an interesting statistic about how, traditional CAD and PLM systems, the usage has gone down quite a bit because many people working from home simply don't have the compute horsepower to run those kind of software packages. But being cloud-based, Onshape didn't experience that kind of that kind of an environment.
Yeah, I found Onshape really interesting. I had to go, free account. I'm not an engineer or anything, but I find these things really fun to use. It's a terrific piece of software, in my opinion. And I didn't know that PTC had acquired it, and it looks like you're right. I don't know when it was, but PTC says here clearly their own website. They've acquired Onshape, and if Rockwell has bought, I don't know if you're saying they bought, but some sort of deal with the PTC, and obviously, that's very interesting. It's a very interesting integration and provides for digital transformation service across the board. I'll go a bit more high level now. I mean, about Rockwell itself. I mean, like you say, I didn't know it was 100 years old, but it's a tremendously well respected and important company in the sector. I mean, what do you think of how do you think the future is going to pan out for it, especially in light of maybe GE's probably difficulties with in recent years with predictive maintenance, their own predicts, well, probably across the company itself, but I don't know if predicts is doing too badly. But how do you think Rockwell will do in the market, and what's the technology offerings going forward?
Well, one of my favorite sayings is edge is the new cloud. The majority of data is going to be processed at the edge, in 5 years, right? There's a lot of reasons for that. Sorry, there's a helicopter. The paparazzi stalk me all the time. I can't help it. The cost of moving data, the cost of security infrastructure, connectivity limitations, right? There's a lot of drivers, latency. There's a lot of drivers to do more and more at the edge. And what there isn't at the edge today is, as you saw in the cloud, now that it's basically 2 to 3 main players, right? And I believe the same will happen at the edge. I believe 2 or 3 companies will figure out the real magic of OT-IT convergence, of analytics and machine learning, and how to work in a closed loop fashion with, the larger cloud providers. It's not anti-cloud. There's a close collaboration with, in our case, Microsoft, for example. But I believe Rockwell, with its global installed base, its presence of 8 or 9 or 10 of the biggest companies in virtually every vertical, we're getting an opportunity to work with them as they go through their digital journey. And I have great faith that Rockwell will be, one of the top companies in digital transformation for the industrial segment. We've already shown quite a bit of momentum there. We did a press release with PTC late last year about our joint customers, our integration work, our recognition of the Innovation Suite platform. So I'm quite excited about the potential for Rockwell to be a dominant player in this fast emerging market of digital transformation, industrial edge solutions, analytics, machine learning, all the artificial intelligence, all the things that you hear about, because a lot of it has to do with really understanding OT data and OT environments. And that grounding, really helps us as we package and shepherd our knowledge and understanding into a variety of digital transformation software solutions, including, enterprise software in some cases. So we have very good high customer satisfaction. We have, as you say, a very good brand. And so I think we're in good shape to be a big player in this movement.
Yeah, just to add to what Keith said here, the cloud war is one at the edge, right? So that's where the data is being generated to do all the analytics. And we being close to the actual asset with our controllers, so I think we are well poised to leverage and exploit the data to provide more value to the customer. The biggest challenge today, like most of the IoT vendors face, is like, how do I get this data to a meaningful way before I have the data scientists to build models and analytics around that? The way we are approaching is like, how can I contextualize this data right in the controller itself, right? So that when this data goes outside, no matter whether it goes to a cloud or it goes to an on-prem data sink, it doesn't matter. The data is represented in an enriched form directly for the data scientist to consume. So what we are trying to do here is, let's make sure that the data is contextualized. It has an asset model. So this all comes at high speed, right? So we need to do this high speed processing of the information, add a context to it, and then push it to the data sink. And that's one of the key investment that we're doing to make sure that some of the initial pains of getting the data together and sanitizing it, clearing the outliers, it's all done at the source itself. Because the biggest thing is all about timestamp. Hey, when you want to track back what happened and you want to track the geology, like what has happened and what are the different parameters when this particular event happened, you need to stitch the data together to find or recreate something that was in the past. And until I have timestamp everything to accurately, I'm not going to be able to get that. So that's what we are trying to also solve here.
Yeah, it's a very interesting and complex field overall, and even for people who maybe feel a bit bewildered like me, I'm not really a software guy, really. I don't know. It's easy to get lost for me, but in terms of the technical side of it. But I basically understand. One thing I've learned is that this kind of digitalization process, predictive maintenance, like one of your slides showed, it really pays off. It's you can make a lot of savings. You make things more efficient and things like that. And I thought maybe you could either one of you or both of you could just sort of briefly summarize, that part of it. I mean, does it have that effect on people? I mean, it's kind of a revelation to find that you can make much more savings. You can make things more efficient with this kind of technology, as difficult as it might be to implement, as you were saying. But yeah, you talk about the benefits of predictive maintenance and perhaps how the market and companies have taken to it, have embraced it over the maybe last year, a couple of years, and going forward as well.
Sure. What I can do is I can pull back up one of the slides that I shared just a little while ago, but I know I went through it very quickly, um, and give you an idea of the ROI that people are expecting from these types of projects. Um, and if we look across, how does digital transformation help me increase my revenue by speeding my time to market, speeding my change of production lines, giving me more agile manufacturing, driving out costs, which improve margin, increasing quality, and increasing yield, reducing scrap. Um, on the operating cost side, the automation benefits, the raw material efficiency, the pure overhead that can be targeted, along with the fact that in many cases you have very high value assets. Manufacturing computer wafers, for example. These are hugely expensive machines that any downtime means, a big impact on your business. So maximizing those very expensive assets, and things like that are some of the main drivers of the highest value use cases that Rockwell customers are leveraging today.
Is this something that people find surprising, how much it can pay off if they do make the investment in this kind of predictive maintenance or digitalization technology?
I don't think any longer. I think that was probably the case, a year or two ago. But, there's been some front runners in digital transformation, some companies that have really gone public with, the results they've generated. And now I think it's viewed as a competitive best practice, to just absolutely get the most out of your manufacturing environment, with the most compelling use cases and the deepest insights. The example used quite recently was around, when this whole virus popped up. A lot of people didn't have their manufacturing systems and their ERP systems and their supply chain very integrated. So when demand fell off, production kept going, and raw materials kept being purchased, right? And had that all been a bit more synchronized and digitally connected, you can be a lot more efficient in backing off, when you see demand fall, and optimizing your, in this case, your supply chain.
Yeah, and Aro, in terms of return on investment, I mean, to achieve, I mean, does it take a long time to get your money back with these savings? I mean, I don't expect you to tell me prices, but is it expensive to implement? I mean, is there a kind of like a picture you can give me, a standard sort of pricing structure or something like that?
It really is very, very different. We have some base analytic products that are in the thousands of dollars, and we have digital transformation, multi-site, initiatives with services and quite a bit more that that are obviously, much more expensive. So I would say that it is pretty easy to get started with some, step one, step two, things like OEE, for example, which is listed here, which is simply, the ability to understand your operational efficiency. Those solutions, are not very expensive to get started and deliver results very quickly. Things like anomaly detection are another example. So there really is quite a range, but it is easy to get started. It is easy to get started at reasonable price points. But certainly, if you're looking at a transformational closed loop prescriptive analytics type solution, it can be could be a bit more pricey.
Just to add to what Keith said, I think companies also realizing like it is not it is a journey. So the industrial transformation is a journey, and there are different aspects to look at it and take this as the opportunity to rethink how things are working today and how they want to move forward. But if you look at the industrial transformation, you need to look at how am I connecting to my devices today? Where am I storing it? What are the tools I have to clean this information that I'm collecting? And am I having it in the right place for people to consume? Then when I consume those data, like do I have tools that I can leverage for me to build, like if I want to do some analysis, do I have enough tools to do those analysis on the data, right? And then once I have those tools to build my models and my analytical models, how do I create an application out of that? And how do I deploy it? Do I need to deploy it in the cloud? Am I deploying it to the edge? So there are different aspects to take care of it. I think it's a learning curve. And 6 years back, it was all new to the companies. So kind of they were looking at where to start. So it was also a journey for them to think in that holistic view. But I think now customers have crossed that bridge, and now they realize the potential and also the investment that it takes for them to realize the value of it. So I think we have crossed that that boundary into, yes, you can leverage the latest technologies, but there is something that we need to have a holistic approach, and there is investment required to realize the value.
Okay, thank you very much for your time and all the insights.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.